Hello everyone, welcome to my YouTube channel. In this video, we will understand the 7805 IC as a voltage regulator. So let's get started. These are the learning outcomes of this video. So first of all, we will discuss why voltage regulation is needed. We know that electronic circuits need a constant DC voltage to work properly, but practical power supplies give unregulated voltage, which changes with load and input supply. To maintain a fixed output voltage, we use a voltage regulator. So what is a 7805 IC? The 7805 IC is a three-terminal linear voltage regulator that provides fixed 5-volt DC output voltage. The number 78 represents that this IC is a positive voltage regulator and 05 represents the output voltage of this IC, which is plus 5 volt. When we say that the 7805 IC is a linear voltage regulator, then what do we mean to say when we say that it is a linear voltage regulator? The linear voltage regulator term represents that this IC uses a series pass transistor which acts like a variable resistor controlled by an error amplifier. I mean to say that there is a pass transistor in this IC which is connected in series and it works like a variable resistor which is controlled by the error amplifier. The pass transistor drops extra input voltage and converts it into heat. Because of this, the linear regulators generally have low efficiency, but still they are very commonly used because of the simple circuit design and low noise. Moreover, they are very reliable to use. This is the pin configuration of 7805 IC. Pin number 1 is the input pin where we connect the unregulated input supply voltage. Pin number 2 is the ground pin, which is also called reference pin. Pin number 3 is the output pin where from where we can get 5 volt DC output voltage. The incorrect pin connection may damage the IC, so we must keep in mind the pin configuration of this IC before connecting this IC into the circuit. These are the internal blocks of 7805 IC. The first block is the voltage reference block, which provides a stable reference voltage. The second block is the error amplifier block, which compares the output voltage of the IC with the voltage reference generated by the first block, and the error amplifier generates an error signal to control the third block, which is pass transistor. So error amplifier basically calculates the error between the reference voltage and the output voltage, and then it controls the pass transistor according to the error generated. The fourth block is current limiting circuit, which protects the circuit against overload and short circuit. The fifth block is thermal protection circuit, which shuts down the IC during overheating. These blocks together ensure safe and stable voltage regulation. Now we will see the working principle of this IC. So inside the IC, the output voltage is continuously compared with the reference voltage. If the output voltage increases, then conduction of the pass transistor is reduced or the resistance of the pass transistor is increased so that more voltage is dropped across it. Similarly, if the output voltage decreases, then conduction of the pass transistor is increased or the resistance of the pass transistor is decreased so that less voltage is dropped across it. So how are we able to control the conduction of the pass transistor or the resistance offered by the pass transistor? Pass transistor is nothing but a transistor working in its linear region or active region, and we know that the conduction of a transistor working in active region or linear region can be controlled by controlling the base current. So the pass transistor is controlled by the error amplifier, and the error amplifier increases or decreases the conduction of the pass transistor according to the error generated, and this error is generated by the error amplifier when it compares the output voltage and the reference voltage. So this automatic control keeps the output voltage constant at 5 volt. This is the formula for power dissipation in the 7805 IC. The formula given here does not represent the output power, but it represents the power dissipated as heat by this IC. The formula is given by P is equal to input voltage minus output voltage multiplied by output current. So in case we want to draw high current, or in case our input voltage is high, then power dissipation will become high, and to dissipate this much amount of power as heat, we will need to use a heat sink. So a heat sink is required for high voltage or high current. These are the advantages of 7805 IC. It is simple and easy to use. It has low cost and it is easily available in the market. It has built-in protection as we have already seen. It is ideal for learning and lab use. These are the limitations of 7805 IC. It has low efficiency. It generates heat which needs to be dissipated using heat sink, and it is not suitable for battery power systems. These are the common applications of 7805 IC: microcontroller power supply, embedded systems, digital logic circuits, sensors, and lab trainer kits. So this was a quick explanation of 7805 voltage regulator IC. If this video helped you, please like, share and subscribe. Feel free to ask doubts in the comments. Thank you for watching.